Hello dear students, welcome once again in our video lecture of redox reaction. This is our fifth lecture of redox reaction and we were discussing about the calculation of oxidation number of an element in any compound. So as far as the oxidation number topic is concerned, this is our third video on oxidation. In previous video, we have seen some examples to find out the oxidation number of an element. Now in this video, we are going to find some more examples about the calculation of oxidation number. But these are some kind of special examples. Most of the examples in today's lecture are not normal. They are abnormal, or you can call it special. Okay, so take your note and pen with you. And I am Jani. This is our YouTube channel for standard 11 and 12 science who are preparing for NEET and G also. We have also videos according to the preparation of NEET and JEE examination. You can browse the videos by clicking the I button over here, looking in front of you in your screen. Okay, so take your note and pen and let us start. So our today's first example is HClO. And we are going to find out the oxidation number of chlorine in this number. HClO, oxidation number of chlorine. So first of all, as this is a neutral species, so the total oxidation number will be 0. And for hydrogen, we will take +1. For chlorine, we are going to find, therefore it is X. And for oxygen, we will take -2 is equal to 0. So here 1 plus x minus 2 is equal to 0. -2 plus 1 will give us -1, and if that -1 goes to the other side of equal to, then we will have +1. So here in HClO, the oxidation number of chlorine is +1. Now look carefully the second example. HClO2. This is only HClO, while this is HClO2. In HClO2, if we are asked to find the oxidation number of chlorine, then also HClO2 equal to 0. For X, we will take +1. Why? Now you know very well that plus X plus 2 multiplied by for oxygen, it is minus is equal to 0. So it is 1 plus X minus 4 is equal to 0. Now this -4 plus 1 will give us -3, and that -3 goes to the other side of equal to, then we will have the value as +3. So if we talking about HClO, then the oxidation number of chlorine is +1, while in HClO2, the oxidation number of chlorine becomes +3. So same element in different compound is having different oxidation states. Third example, HClO3. Now, if we are asked to find the oxidation number of chlorine in HClO3, then what will happen? So again, for hydrogen, or we will write HClO3 is equal to 0 as it is a neutral molecule, and +1 plus for chlorine, we will put X, and 3 multiplied by oxidation state of oxygen, that is -2, equal to 0. Okay, now let us simplify it. 1 plus X minus 6 is equal to 0. -6 plus 1 will give us -5. Goes to the other side, then it will become +5. So here again, the same element chlorine, but in different compound, its oxidation state is also different. One more example of a compound having chlorine, HClO4. Now, if we want to find the oxidation state of chlorine in HClO4, then HClO4 equal to 0. Then +1 plus X plus 4 multiplied by -2 is equal to 0. Now 1 plus X minus 4 to the 8 is equal to 0. -8 plus 1 equal to -7. And if it goes to the other side of equal to, then we will have +7. So chlorine can have plus 1, plus 3, plus 5 as well as plus 7 oxidation states in its different compounds. And just remember the example of HCl. In HCl, the oxidation state of chlorine was minus. So chlorine can have a variety of oxidation states, minus 1, plus 1, plus 3, plus 5, plus 7. And if chlorine is alone, then its oxidation state will be 0. So from seeing these examples, we can conclude that chlorine can have a minimum oxidation state equal to minus 1 and a maximum oxidation state equal to plus 7. These are the two extremes of the oxidation state of chlorine, minus 1 and plus 7. Okay, let us take some more examples. Suppose if I write the compound like this, NH4NO3, and we are asked to find the oxidation states of both these nitrogens in this compound. Now here we are asked to find the oxidation state of two different elements. It means elements are same, but they are in different positions. So in that case, you cannot find the oxidation state of nitrogen by just writing N2H4O3. It will be not correct because this is an ionic compound. So you have to divide both these ions and you have to calculate the oxidation state of nitrogen separately for both the ions. Okay, so first of all, let us divide this compound into two different ions. One is NH4 plus 1 and the other is NO3 minus 1. NH4 plus 1, NO3 minus 1. Now we will separately find the oxidation state of nitrogen in both these species. So first of all, NH4 plus 1 is equal to plus 1. And if nitrogen is to be defined, then let us put it X over here. X plus 4 multiplied by, for hydrogen oxidation state is plus 1, is equal to plus 1. So here, X plus 4, 4 ones are 4, is equal to plus 1. Now this 4 goes to the other side, then it will become minus 4. Minus 4 plus 1 will give us minus 3. So oxidation state of nitrogen in NH4 plus is minus 3. So this nitrogen has minus 3 oxidation state. But as far as second species is concerned, let us calculate this also. NO3 minus 1 is equal to minus 1. Here we have to write the charge which is situated on the species after equal to sign. Here we put 0. Why? Because these are neutral species. There is no charge on these species. Therefore, we have written 0 after equal to. But here charge is given. Therefore, we have written the charge. Okay. Now once again, oxidation state of nitrogen, that means X plus 3 multiplied by oxidation state of oxygen is always minus 2 in most of the compound and is equal to minus 1. Now X minus 3 to the 6 is equal to minus 1. Now if this minus 6 goes to the other side, then it will become plus 6. And plus 6 minus 1 will give us plus 5. So the oxidation state of nitrogen in this compound, this species, is plus 1. So here, in a same molecule, we have two nitrogen atoms and the oxidation state of both these nitrogen atoms are different. So these kind of compounds are also possible in which a same element is having different oxidation states. So this is a very special kind of example, NH4NO3. The name of this compound is ammonium nitrate. Ammonium nitrate, in which one nitrogen, which is of ammonium ion, is having oxidation state minus 3, and the other nitrogen from NO3 ion is having oxidation state plus 1. Okay, so pause the video and just write down these examples. Okay, now let us move further. Okay, now if I write Fe3 Fe3O4. Fe3O4. And if somebody asks what is the oxidation state of iron in Fe3O4, so first of all, to find the oxidation state of iron in this compound by our simple method, then oxidation state will have a fractional value. Let us take out. So Fe3O4 is equal to 0. Why we put 0 over here? Because this is a neutral species. Okay, now if we want to find the oxidation state of Fe, then let us consider it as X. But here we have 3 Fe, so we will write 3X plus 4 multiplied by, for oxygen, obviously it is minus, is equal to 0. Now 3X minus 4 to 8 is equal to 0. That means 3x is equal to plus 8. That means x is equal to plus 8 by 3. Now this is a fractional. This is not a point. Oxidation state in fractional number. Now what is oxidation state or oxidation number? If a covalent bond is situated between two atoms, then electronegative atom pulls the bonding pair of electron towards itself. This number of electrons which are pulled is considered as the oxidation number. Now, if an element is pulling the bonding pair of electron or electron from the bonding pair, then electrons must be in a whole number. Some element can pull 1 electron, can pull 2 electrons, can pull 3, 4, 5, 6, 7 electrons. But you cannot say that the element is pulling 8 by 3 elements. 8 by 3 electrons towards itself. It is not possible. Electrons cannot be in a fractional number. Now, I have to give you one word for this. There is a word quantum. Now, we have to understand about this word quantum. So, just listen carefully. This is the word most of the students have no idea about it. They just speak quantum, and they have finished their study also. But still, they have no idea about what the quantum is. Now, quantum is a word which is derived from a word quantity. Quantity and quantum. A smallest unit of a large quantity and the unit which is not divisible is considered as quantum. That is, smallest unit of a quantity which cannot be divided further is considered as quantum. Now let me give you one example. Suppose there is a tanker filled with milk. So there is a large quantity of milk filled in that tank. And when that tanker goes to any dairy and some pouch of milk are made, they are sold in the market. The pouch contains a half liter, 500 ml of milk. But each pouch is considered as the quantum of that quantity of milk. In a container, there is a large, huge quantity of milk, but that milk is now packed in a separate pouch. Each pouch is considered as the quantum of that milk. Now, why I am saying it a quantum? Because it is indivisible. It is in a whole number. If you go to any shop and if you ask that, I want 1 pouch of milk, then you will easily get it. If you say, I want 3 pouches of milk, you can get it. But if you say, I want 1.5 pouches of milk, the shopkeeper will not give you that. Because pouches are always in a whole number. You can buy 1 pouch, 2 pouch, 3 pouch or 10 pouches. But you cannot buy 2.5 pouch of milk. That is what quantum is. Quantum is a smallest unit which cannot be divided further. So electron itself is a quantum. You cannot break the electron. Electron is always in volume. An element can have 1, 2, 5, 7, 8, 10, 20, 100 electrons. But an element cannot have 2.5 electrons or 8 by 3 electrons. This is not possible. So practically this answer is not considered as the correct answer. Now let me give you one more example of quantum entropy. A human crowd, so many people gathered, is considered as quantity of humans, and each person is considered as quantum. Why? Because a person is always as a whole. We cannot divide any person in 2 or 3 parts. When you were small kids and traveling with your mother and father in bus, state transport bus, then your father bought the ticket in this manner. You, your father, your mother, that means 3 persons are traveling in a bus of state transport. And if conductor comes and asks, how many tickets I will give you? So your father says him that give us 2.5 tickets. That means you are 2.5 person? No. 2 persons which are adult and 1 person, that is you. Though you are not adult, but you are a complete person. You are not a half person which is cut. So all human being is also considered as one. Because if they are, then they are as a અડધા માણસ એવું ન હોય, અડધી ટિકિટ હોય. અડધી ટિકિટ એટલે નાના બાળકની ટિકિટ, પણ માણસ અડધો નથી. So that is what the quantum is. One more example. A ladder which contains so many steps is considered as a quantity, and each step is considered as one. If a ball is on first step, or it can be on second, third, fifth, eighth, 10th step, but you cannot place any ball between second and third step. It can be either on second step or on third step. So each step is considered as one. So okay, this is all about quantum, and electrons are quantum. They are quantized. That means they cannot be in fractional number. That means we have to correct our answer. But this is not completely incorrect. This is an average oxidation number of all these 3. And if you find average, then there can be a fractional number. When you have the value of average of anything, then it can be fractional. But if you see individual values, then the values of oxidation number is always in volume. Okay, now let us find the individual oxidation state of all the iron elements. Here we have 3 Fe, but all these 3 Fe are not having the same oxidation state. Why? Because in Fe3O4, there are 2 molecules mixed together. It contains FeO and Fe2O3. FeO and Fe2O3. Now, if we add both this formula, then we will get Fe0, Fe3O4. Now, if we separately find out the oxidation state of iron in both this compound, then we will have a whole number value. Let us find it. FeO is equal to 0. Now, X for Fe plus for oxygen minus 2 is equal to 0. That means X is equal to plus 2. So here the oxidation state of this Fe is plus 2. The compound is known as ferrous oxide. This is ferrous oxide. Now let us count the oxidation state of this iron in Fe2O3. So Fe2O3 is equal to 0. Now we will put X for Fe. That means 2 multiplied by X plus 3 multiplied by minus 2 is equal to 0. That means 2X minus 3 to the 6 is equal to 0. That means 2X is equal to plus 6. That means X is equal to plus 3. So here each Fe is having oxidation state as plus 3. Now the oxidation state of both these Fe's are in whole. This Fe is in +2 and these two Fe are in +3. The name of this compound is ferric oxide. So in Fe3O4 there are two different compounds, ferrous oxide and ferric oxide. Ferrous and ferric oxide are mixed together, then it will be Fe3O4. And what will be the name of this mixture? This is, just listen carefully, ferrous oxide plus ferric oxide, that means ferrous, and ferric oxide, that means ferroso-ferric oxide. Again, ferrous oxide plus ferric oxide, that means ferrous, and ferric oxide, that means ferroso-ferric oxide. So name of the compound is ferroso-ferric oxide, which contains total 3 Fe, and they are of two kinds. One is in +2 and two are in +3. Now, let us count the average oxidation state for all these Fe. Average means the total number of Fe divided, total charge on Fe divided by the total number of Fe. Now, what will be the total charge? 2 plus 3 to the 6. 1 Fe is in +3. Here we have two such Fe. That means the total charge will be +3 multiplied by 2, that is +6. So here the total charge of Fe, average oxidation number of Fe, is equal to total charge divided by total Fe. Now total charge is 6 plus 2, that is 8, plus 8, divided by total number of Fe, 2 plus 1, that is 3. Now these are the same way. So now you can understand what is the fractional number of oxidation state means. If oxidation state of any element is fractional, then consider it as an average oxidation state. That means there are more than one kind of oxidation state for the same element in that. So this is about Fe3O4. One more example is Pb3O4. That is plumbo-plumbic oxide. As this is ferroso-ferric, there is one more plumbo-plumbic. We will discuss about it also. Okay, first of all, write these topics by pausing the video in your. Okay. Now, some more special examples. Just look carefully what I am going to write. C, double bond C, double bond C, double bond O, double bond O. If you want to write the formula for this compound, then it will be C3O2. C3O2. The name of this compound is carbon suboxide. This is carbon suboxide. Carbon suboxide. Carbon suboxide. Now here we have three different carbons, and if you find the total oxidation state of carbon by using this formula, then you will get a fractional. Let us count the oxidation state of carbon from this carbon suboxide. So it is C3O2 is equal to 0. 3 multiplied by x plus 2 multiplied by minus 2 is equal to 0. That means 3x minus 4 is equal to 0. That means x is equal to plus 4 by 3. So it is a fractional number. So the oxidation state, or we should say average oxidation state of carbon in carbon suboxide is plus 4 by 3. This is average. That means all carbon are not having same oxidation state. They are in different oxidation state. Now let us count. It is very simple for to count the oxidation state of any element from a structure. So here both oxygen must be in -2 oxidation state. and carbon which is attached with oxygen and it is also attached with another carbon. In that condition, the oxidation state of this carbon will be plus 2. As this is minus 2, to neutralize it, carbon must be plus 2. Here also, this oxygen is in minus 2. That means to neutralize its charge, this carbon will be plus 2. Now, here, this carbon is attached with carbon only. And the electronegativity difference between two carbons is 0. Because all are carbon. They are having same electronegativity. So, these electrons cannot be pulled through any carbon. Remember the first lecture, the definition of oxidation state. The bond between two different elements having electronegativity difference, in that case, the bonding pair of electron is pulled by the electronegative species. But here, all are carbon. So, there will be no pulling between them. So, here, this carbon or electron of this carbon are not pulled by any. And if electrons are not pulled, then the oxidation state of this carbon is considered as 0. Okay, now the average oxidation state of carbon. If we want to find the average oxidation state, average oxidation number of carbon is equal to total charge on carbon plus 2 plus 0 plus 2, that is plus 2, divided by total number of carbon, that is 3. So it is plus 4 by 3. So this is the average and these are the individual oxidation state of each carbon. So if question is asked, what is the oxidation state of carbon in carbon suboxide? So your answer will be 2 carbons are in plus 2 oxidation state and 1 carbon is in 0 oxidation state. Okay, let us consider one more. Now this is the last for today's lecture. Br, double bond O, double bond O, double bond O. Here also double bond O, and here also we have the O. Now, if you write the molecular formula for this compound, then it will be like this: Br3, as there are 3 bromine, and O8, 3 plus 3, 6 plus 2, 8. Br3, O8. The name of this compound will be tribromo. Tribromo octaoxide. You can write the name by just seeing the formula also. Tribromo. Tri means 3. Octa means 8. Tribromo octaoxide. Tribromo octaoxide. This is the name of this. Now let us find the average oxidation state of bromine in this. So it will go like this: 3 multiplied by x plus 8 multiplied by minus 2 will be equal to 0. So it is 3x minus 8 to the 16. 8 to the 16, but it is minus 16 is equal to 0. So 3x is equal to plus 16. So x is equal to plus 16 divided by 3. Now this is also a fractional number. So obviously it is an average oxidation number of bromine. So all bromine are not having same oxidation state. They are having different. Now let us count. All oxygen are in minus 2. All oxygens are in minus 2. So if all oxygens are in minus 2, then the oxygen attached with bromine, then such bromine will have the charge which can neutral the total charge of oxygens. So here the total charge is minus 6, negative 6, 2 plus 2 plus 2, that is 6, minus 6. So this bromine will have plus 6 oxidation state. These 3 will give us total minus 6. Therefore, to neutralize it, this bromine must have plus 6. Same condition can be applied in this end also. Minus 6, so this must be plus 6. But here, if you consider this bromine, then it has only 2 oxygen attached with it. Minus 2 and minus 2, that means minus 4. So to neutralize it, this bromine must have plus 4 oxidation state. And as this bromine is attached with two bromine, bromine and bromine, no electronegativity difference. Therefore, there is no need to count the effect of these bromines on this. Okay. So these are the total oxidation states of all the elements. Now let us find the average oxidation number of bromine is equal to total charge 6 plus 4, 10 plus 6, that is plus 16 divided by total number of bromine. There are, so it is plus 16 by 3. This is the average oxidation state. Okay, now I think the video crossed the time limit, which is 20 to 25 minutes. So we will stop our discussion at this point, but still one more lecture will be on the calculation of oxidation state. And in that video, we are going to see some more examples about the calculation of oxidation state. So this is very important topic. That's why I am making more videos about it. So there is no need to speed up our course. All the things which we are going to learn should be understood properly. The concept should be clear. That only works. Okay, so pause the video and just write down these examples. And if you like the video, then press the like button. If you don't have subscribed yet this channel, then please subscribe channel. Press the bell icon as well. Share this video among your friends. This is free for all. I am not making the unlisted video. I am making video public. So all students who are studying in standard 11, standard 12, and if they are preparing or they are dedicated for the study, then this video is for all those students, dedicated to all those students. So share this video, and till we meet next time.